There's a new virus in the database.
We have a zero bug attacking all login and overlay files.
Run antivirus. Give me a systems display.
Down 176 and 26.
G'day and welcome everyone to this new episode of The Rising Cyber. In our efforts to always introduce you to new aspects within cybersecurity, today's topic will be regarding EV, electric vehicles security. Understanding what is electronic EE architecture, which will give us insight on how such systems are vulnerable to cyber attacks. As it is important for any cybersecurity professional to engage and understand not only the IT side of cybersecurity, but the operational technology side to enrich and add more experience and expertise under their belt. It's worth mentioning that 8.4% of all new cars sold in 2023 so far have been EVs. This is more than 120% increase compared to all of 2022. So if you are planning to buy your first EV, this episode is for you. A warning about this episode that there will be many technical terminologies and acronyms. You don't have to worry about them, just focus on understanding the wider concept. As we mentioned earlier, building any electrical vehicle is based on the electrical and electronic architecture, which is the set of electrical wires, electronic components, networking topologies, and a set of applications all packaged to provide control over the vehicle and an overall user experience managing all that. Understanding the fundamental concepts of the EE architecture is a requirement for analyzing vehicle security and its attack surface. To be able to do so, we'll discuss electronic control units, ECUs, and their domains, exploring the vehicle network and its set of applications and APIs, touching on the subject of sensors and actuators. An actuator is a component that can be electronically controlled to move a system. We'll go through the EE architecture as brief as possible, as I want to spend more time on the cyber threat landscape of the EVs. But without basic understanding of this architecture, it will be meaningless. There are multiple layers within the electric architecture, starting with the ECUs, electronic control units, as mentioned. The ECUs are grouped in domains, which are interconnected by sets of in-vehicle network communication channels. The ECUs are further connected to sensors and actuators through a mixture of hardwired and network-based connections. The combination of ECUs, sensors, actuators, and network channels can be arranged in different configurations, giving rise to several variants of the vehicle electronic architecture. ECUs consist primarily of processing elements and electronic components necessary to perform any vehicle functions, such as steering, seat belt controls, braking controls, ABS, and dashboard displays. ECUs is the heart of any architecture configuration, and therefore they are housed securely and sealed in enclosures that are designed to withstand harsh environment conditions such as heat, water, and vibration. One of the most important features for any ECU is its ability to perform in real time and with high degree of accuracy, making it a very time-sensitive device with milliseconds function rate. For example, deploying airbags or braking accuracy is a matter of life and death. Therefore, a certain standardization was required, and AUTOSAR was created. AUTOSAR stands for Automotive open system architecture. AUTOSAR is a worldwide development partnership of vehicle manufacturers, suppliers, service providers, and companies from the automotive, electronic, semiconductor, and software industries. A key feature of AUTOSAR Adaptive is the transition from signal-based software design to a service-oriented architecture, SOA. Rather than a monolithic software image built for a specific ECU, AUTOSAR Adaptive offers a flexible architecture that allows for a dynamically updated and deployed application. Overall, AUTOSAR Adaptive can be hosted directly on a single hardware platform or even on a virtual machine. Now moving into the domains and the in-vehicle network. If ECU is the heart, now think of in-vehicle network as the nervous system and the sensories and actuators as our senses. Grouping ECUs is what we call domains. Domains collaborate to achieve a function in a vehicle, such as activating your brakes or the advanced driver assistance, ADAS control. Now in the vehicle network, which is what ECUs rely upon in their communication, we use controller area network, CAN, Ethernet, and local interconnect network, LIN. The increased demand for network bandwidth is constantly driving the in-vehicle networks to transition to higher bandwidth solutions such as Ethernet and GMSL. The Society of Automotive Engineers defined many standards regarding CAN and Ethernet, one of which is J1939 standard, which operates on the OSI network layer 3, 4, 6, and 7 presentation, session, and application. Now, briefly regarding the sensors and actuators, they provide us with a 360-degree sensor mapping, collision avoidance, pedestrian detection, traffic sign recognition, and so on. So next time while your Tesla is doing the driving for you, know that these are the set of technologies working behind the scenes, making it a reality. So far we have painted a clear picture of the architecture and peeled some of its important layers. We'll switch into the security mode now, and before you say anything, no, we are not going to open Tesla's charging port with a Flipper Zero device just yet. We'll review some fundamental security concepts, methods, and principles that are essential in the automotive and electrical vehicle use case. In the most general basic terms, a cyber attack is an attack that will compromise the CIA confidentiality, integrity, and availability of data and systems. In an automotive setting, an attack is an action that is performed by an adversary that aims to either compromise the vehicle information or the vehicle's ability to carry out its operational, security, or safety objectives. One example would be to bypass electronic security systems to facilitate the vehicle theft, or even worse, which is causing a victim to crash. If interested, MITRE has prepared a full attack matrix regarding the Industry Control Systems, ICS, which will provide you with a full list of the attack's tactics, technique, and procedures. If you worked on any red teaming activities, you must have applied some sort of passive attacks, reconnaissance, or adversary in the middle on networks. Same could be applied on the in-vehicle networks. Listening to CAN, controller area network, and Ethernet frames using a tool called Vector Canalizer. Like picking up messages from the brakes, ECUs, for example, and understanding how this communication takes place. Now all these attack types mentioned here will be presented from the electric vehicle context. But if you work in cybersecurity, you'll be familiar with some of their activities from the label or even from their attack name. Like spoofing attacks. Here, when a fake diagnostic tester initiates a diagnostic session and requests a restricted service, resulting in the execution of privileged services such as rolling back the odometer to a lower mileage value. Replay attacks, where its objective is causing the target to react to old data. If the target ECU does not check for updated version of its data, then replay attacks become possible, resulting in increasing the engine torque, for example. Denial of service DOS attacks have a wide scope in automotive systems. An example of a powerful DOS attack is erasing the ECU firmware, resulting in breaking the ECU domain. This happens when a DOS attack is transmitting back-to-back CAN messages with the highest priority CAN identifier to deny other ECUs access to the shared CAN bus, rendering this unit out of service, such as your brake control, for example. Now let's talk cryptography a little bit here, starting with Message Authentication Code Algorithm, MAC. MAC prevent the hash value from being forged by introducing a symmetric secret key into the code. It's used to protect the integrity in the in-vehicle messages. One of the most used algorithms is the AES CMAC algo. We won't go into the process of how the PDU protocol data unit uses a 128-bit symmetric key MAC for encrypting data, as it's a complicated process, but nevertheless, it's good to know what level of encryption keys and what type of algorithms are in use. Another cryptographic method is Random Number Generator, DRBG, which is standardized by NIST SP 890A. It's worth mentioning that within the automotive context, some of the cryptography used are based on the Chinese cryptography function. For example, Chinese function SM2 mirrors to 256-bit elliptic curve Diffie-Hellman. SM4 mirrors to a 128-bit block cipher, and SM9 mirrors to a digital signature key exchange. There is an urgency to move to what is called PQC, or post-quantum cryptography, in the vehicle industry, as many vehicles produced today will be vulnerable in 2030. So you'll start hearing about crystals, dilithium and crystals, Kyber, as an approved post-quantum cryptography algorithms in use within the industry. We'll stop here, as the intention is not to teach you how to hack these vehicles, but to present a basic understanding of the electronic architecture and some of the most popular attack types, providing some examples and scenarios. The attack surface from USBs, Wi-Fi's and Bluetooth are being exploited heavily, with new gadgets being developed and continuously updated like Flipper Zero and PortaPack H2, which I'm seeing it's being included as part of some red teaming's arsenals, and unfortunately malicious criminals as well. Other tools used by pen testers such as Cellsite, Car Whisperer, Xscope, Keysight SA8710, a wonderful machine, just to name some here. Software and API vulnerabilities remains the biggest threat vector for any EV manufacturer. Better firewalls connecting IIoT's Industrial Internet of Things is required, and a reliable and mature DevSecOps for secure software development within the industry. We have just scratched the surface today in a very complex and emerging cyber world. So, before purchasing any electric vehicle, It will be good to do your homework and buy ones with the highest safety rating. That will be all. Thanks for listening and always drive safe.
The Rising Cyber by Chad Sally B.